Let's get some practice calculating interquartile ranges. And I've taken some exercises from the Khan Academy exercises here, and I'm just going to solve it on my scratch pad. The following data points represent the number of animal crackers in each kid's lunchbox. Sort the data from least to greatest, and then find the interquartile range of the data set. And I encourage you to do this before I take a shot at it. All right, so let's first sort it. And if we were actually doing this on the Khan Academy exercise, you could just drag these, you could just click and drag these numbers around to sort them, but I'll just do it by hand. So let's see, the lowest number here looks like it's a 4. So I have that 4, and then I have another 4, and then I have another 4. And let's see, are there any 5s? No 5s, but there is a 6. So then there's a 6, and then there's a 7. There doesn't seem to be an 8 or a 9, but then we get to a 10. And then we get to 11, 12, no 13, but then we get 14. And then finally we have a 15. So the first thing we want to do is figure out the median here. So the median is the middle number. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So there's going to be just one middle number. I have an odd number of numbers here. And it's going to be the number that has 4 to the left and 4 to the right. And that middle number, the median, is going to be 10. Notice I have 4 to the left and 4 to the right. And the interquartile range is all about figuring out the difference between the middle of the first half and the middle of the second half. It's a measure of spread, how far apart all of these data points are. And so let's figure out the middle of the first half. So we're going to ignore the median here and just look at these first 4 numbers. And so out of these first 4 numbers, since I have an even number of numbers, I'm going to calculate the median using the middle 2 numbers. So I'm going to look at the middle 2 numbers here, and I'm going to take their average. So the average of 4 and 6, halfway between 4 and 6 is 5. Or you could say 4 plus 6 is equal to 10. But then I want to divide that by 2. So this is going to be equal to 5. So the middle of the first half is 5. You can imagine it right over there. And then the middle of the second half, I'm going to have to do the same thing. I have 4 numbers. So I'm going to look at the middle 2 numbers. The middle 2 numbers are 12 and 14. The average of 12 and 14 is going to be 13. If you took 12 plus 14 over 2, that's going to be 26 over 2, which is equal to 13. But an easier way for numbers like this, you say, hey, like 13 is right exactly halfway between 12 and 14. So there you have it. I have the middle of the first half, this 5. I have the middle of the second half, 13. To calculate the interquartile range, I just have to find the difference between these two things. So the interquartile range for this first example is going to be 13 minus 5. The middle of the second half minus the middle of the first half, which is going to be equal to 8. Let's do some more of these. This is strangely fun. Find the interquartile range of the data in the dot plot below. Songs on each album in Shane's collection. And so let's see what's going on here. And like always, I encourage you to take a shot at it. So this is just representing the data in a different way, but we could write this again as an ordered list. So let's do that. We have one song, or we have one album with 7 songs, I guess you could say. So we have a 7. We have 2 albums with 9 songs. So we have 2 9s. Let me write those. We have 2 9s. Then we have 3 10s. Cross those out. So 10, 10, 10. Then we have an 11. We have 2 12s. 2 12s. And then finally we have, so I used those already, and then we have an album with 14 songs. 14. So all I did here is I wrote this data like this. So we could see, okay, this album has 7 songs, this album has 9, this album has 9. And the way I wrote it, it's already in order. So I can immediately start calculating the median. Let's see, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. I have an even number of numbers. So to calculate the median, I'm going to have to look at the middle 2 numbers. So the middle 2 numbers look like it's these 2 10s here, because I have 4 to the left of them and then 4 to the right of them. And so since I'm calculating the median using 2 numbers, it's going to be halfway between them. It's going to be the average of these 2 numbers. Well, the average of 10 and 10 is just going to be 10. So the median is going to be 10. Median is going to be 10. And in a case like this, where I calculated the median using the middle two numbers, I can now include this left 10 in the first half, and I can include this right 10 in the second half. So let's do that. So the first half is going to be those 5 numbers, and then the second half is going to be these 5 numbers. And it makes sense because I'm literally just looking at first half is going to be 5 numbers, second half is going to be 5 numbers. If I had a true middle number like the previous example, then we ignore that when we look at the first and second half, or at least that's the way that we're doing it in these examples. But what's the median of this first half if we look at these 5 numbers? Well, if you have 5 numbers, if you have an odd number of numbers, you're going to have one middle number, and it's going to be the one that has 2 on either sides. This has 2 to the left, and it has 2 to the right. So the median of the first half, the middle of the first half, is 9, right over here. And the middle of the second half, I have 1, 2, 3, 4, 5 numbers. And this 12 is right in the middle. You have 2 to the left and 2 to the right. So the median of the second half is 12. Interquartile range is just going to be the median of the second half, 12, minus the median of the first half, 9. Which is going to be equal to 3. So if I was doing this on the actual exercise, I would fill out a 3 right over there.